Hey everyone, welcome back to Smart Architectural Programming, where we decode the architecture of programming cleanly, clearly, and with style. In today's video, we're diving deep into the essential but sometimes misunderstood topic of the protected access modifier in Java. This is a special bonus companion video for readers of our book Introduction to Java. So if you've got your book nearby, perfect. If not, stick around. We're still going to learn a ton. So without further ado, let's push forward into understanding the protected access modifier in Java first. So what is the protected access modifier? So it's a at the very basic level, Java has 4 access levels: private, default, protected, and public. Among these, protected is the kind of a middle child, often overlooked but incredibly useful when trying to understood and used correctly. So protected means the member is accessible within its own package and subclasses. Even if those subclasses are in a different package, it's more permissive than default, but less so than public. I think I've covered these 4 access levels in Java before in a previous video, so I'm just going to focus on the protected level in detail in this video. As you can see, by package we mean an entire software, right? Or software package here. That's the presumption you need to take at this point, right? So in that entire package, you can use that particular protected variable within its subclasses, right? And it's a little more permissive than default, but less so than public. Let's just keep that in particular thing in our mind. We see a code base here, right? Let's bring on my marker again. You see, let me get a better color here so we don't have problems. So let's try to use green. Yeah, let's use green. So as you can see, we have a package animals here, where we have a public class animal here. Then we have a protected void make sound function. So we have a protected method within the class, which is print make sound, which says some generic, it prints some generic sound there, right? So what does this mean? It means classes in the same package and subclasses in other packages can access this value. So keep that in mind. This is the important lesson that you're going to take out of this video. Classes in the same package and subclasses in other packages can access this method. So let's understand further this concept by representing protected members in UML diagrams. UML diagrams are things like these, right? You can understand this as some sort of a relationship diagram that we are building between different packages, different functions in a software, right? Because if you're a visual learner, UML or Unified Modeling Language diagrams are a great way to represent class relationships, including visibilities. In UML, protected members are marked with hash, basically. And you can find here in this particular section, I don't think we have any hashes here, but basically in UML, we'll find hash marks next to values which are protected or methods which are protected. So just keep that in mind. So the make sound would be represented as hashtag make sound function, right? Make sound. I'm just gonna write it like this. I'm not just gonna go into too much detail. So make sound function would have hashtag in front of the UML diagram here, which means it's protected. Once you master this notation, it becomes a superpower for reading and communicating software designs clearly and effectively. So it was just, I think, a little bit digression into UML designs, but let's get back to our topic. So, how do you declare, a package with protected members? So, you'd organize classes and members in a Java package with protected access. Say we have a package called animals, as you can see here, and inside it we have a class called animals, as you can see here. Oh boy. We love animals with the amount of examples we're using with animals in this chapter. So, and into the protected, as you can see, this protected keyword here, protected method called make sound, right? Makes sense? So the method is visible to all other classes in the animals package. And here's the twist. Also to subclasses outside the package. Again, this is the core method thing that I'm emphasizing in this video. It's accessible to all of it is accessible and visible to the entire package, and it's visible to classes, subclasses outside the package as well. So how do you access protected members from another package, right? And as keep in mind, subclasses can access protected values from another package. So to test that visibility, what happens if a subclass animal from another package? Basically, we subclass animal from another package, right? So we're creating a subclass. We have a package zoo, right? We're using this is the package zoo. We're importing animal class from the first package that we created, and we create a class called lion, which extends from the animal class that we're inheriting from the other package. Here we say roar, which is our make sound for here, but we use the make sound function. It's accessible, as you can read here, because lion is a subclass of animal. Simple enough, right? But if we have package zoo and we have a class called zookeeper, and because there's no animal class, it doesn't extend. It's a completely different superclass or parent class. It isn't a child class, so this cannot inherit or use values from another superclass. So when we try to use the animal.makeSound, there's a compile error because this is not a subclass. This is a completely different class. So it's a in another package, you can only access protected values when you are the subclass where the protected value is, basically. So with that understanding, let's push forward into pattern matching for switch and protected members and understanding that concept here. So this is something more advanced and exciting, and I don't want you to put your put too much of your brain power onto this, but just get a feel for it, right? Pattern matching for switch was introduced in Java 21. So let's say we have a class hierarchy using protected fields, and we want to switch on type in pattern matching way. Even though sound is protected, as you can see in this code below, we have protected sound here. You can still match on types in a switch, but direct access to protected fields need care. You can access them through switch, but it needs to be used in in very, very careful way, basically. So if make noise is a subclass, as you can see here, this is a pattern matching example we have here. If make noise here is a subclass or the same package, this works. Otherwise, you'll need accessors to move further. And again, I'm not going to go too deep into it. This is just a brief teaser into the advanced things that you could do with the protected values and leveraging them. So to recap, here's what we covered in this video: what protected means and where it applies, how to visualize protected members using UML, how protected access works across packages, accessing protected members through inheritance, and a glimpse into Java's pattern matching with protected members. So if you find this video helpful, make sure you like, subscribe, and hit the bell icon so you don't miss any chapter or chapter companion videos for Introduction to Java book. And hey, drop a comment below if you want a deeper dive into Java 21's features and what is new in Java 21. Until next time, keep coding with structure and style here at Smart Architectural Programming. Bye for now.